All right, we're back in chapter 7 with polynomials, but today we're going to start in on the operation of multiplying polynomials. And we're actually going to work on multiplying a monomial times a polynomial. So that would be one term times something with more than one term is what we're going to be working on today. Now, what we're going to be doing is it kind of looks like this. So it'll have a monomial on the outside, and it'll have a grouping with 2 or 3 or 4 or whatever things inside, terms inside. So basically what this is the distributive property. We're going to multiply, like in this example, the 3x or the monomial to each term of the polynomial. And then, if possible, combine the like terms, make sure we write our answers in standard form. Now, the biggest key here that we have to be careful of, and that is we have to be careful of exponent rules. Exponent rules come back into play when we multiply. When you add or subtract, exponents don't change. So if I take 4x squared and I add it to 3x squared, I have 7x squareds. But if I take 4x squared and I multiply it to 3x squared, then I get 4 times 3, which is 12, x squared times x squared, which is x to the fourth. So when we multiply, exponents change. But when we add, just the coefficients change. All right, so let's take a look at this. So we're going to go through several of these. We're going to start off with just a straight up multiply the polynomials and write in standard form. So what I'm going to start off with is my monomial is the 6. I'm going to take that and multiply it to each term. So I start off 6 times 3x squared, 18x squared. 6 times 5x, and then 6 times negative 4. And then I double check, can I combine any like terms? Nope, everything's different. And then am I in standard form? And the answer would be yes, because I start with x squared and I go down in degree each time. Okay, here we go. So now we're going to multiply by 2x to each thing. So I take 2x times x squared. That's going to give me 2x to the third. Because remember, that's x to the first times x to the second. We would add those exponents. 2x times negative 8x. So 2 times negative 8 is negative 16. X to the first times x to the first gives me x to the second. And then the last one, 2x times 1. That's just going to give me 2x. Nothing is alike. I'm written in standard form from greatest to least, and that would be my final answer. Let's try this third one. So this time I'm going to take negative 5x cubed, and I'm going to multiply it to 5x. So 5 times negative 5 is negative 25. X to the third times x to the first gives me x to the fourth. Then I multiply to the next thing. Negative 5x to the third times negative 4. That's going to give me a positive 20. And there's no other x's, so it'll just stay x to the third. Multiply to the 6x squared. So that's going to give me negative 30 x to the fifth. Now I look. My next thing I look at is, am I in standard form? And the answer would be no, because x to the fifth has a higher degree. So I'm going to move some things around. So negative 30 x to the fifth minus 25 x to the fourth plus 20 x to the third. And that would be our final answer. Okay. Now we can also put this together with what we did yesterday with the adding and subtracting. So this time we're going to multiply and add the polynomials. Remember, we're going to look to combine any like terms that we have and then make sure we write it in standard form. So the first thing we're going to do is we're going to do our distributing. So I'm going to start off here and I'm going to take the 3 multiplied to the 4x. That's going to get me 12x. 3 times the negative 5, that's going to give me negative 15. Then I take 2 times 9x, and that gives me plus 18x. And positive 2 times 6, that's going to get me plus 12. Then I look for like terms. Well, I have 12x and 18x. So when I add those together, I get 30x. Then I'm going to take negative 15 and add it to a positive 12, and that would get me a negative 3. Okay, let's try this next one. So on this next one, I'm going to start with the 4. So I'm going to multiply by 4 to each. So that's going to get me 8x squared. Then I take the 4 times the negative 4x, and that's negative 16x. Then I'm going to take the 4 times the 3, which is 12. Now, be careful here. Remember, you're distributing a negative 5. So negative 5 times x, negative 5x, negative 5 times negative 6 is a positive 30. The next thing I look for is like terms. So I first start off, I'm going to look for x squareds, and there aren't any other ones, so I'm going to keep 8x squared. The next one I look for is I start in with the x, so 16x. So I have a negative 16x minus 5x. That's going to give me a negative 21x. And then the last one I'm looking for, I have a positive 12 and a positive 30. That's going to give me a positive 42. I'm in standard form. Nothing else can combine. So that would be my final answer. Okay, let's try this last one here. So on this one, you'll notice I'm distributing a 2x. So 2x times 4x, that's going to get me 8x squared. Then I go 2x times negative 3, that's a negative 6x. Now I'm going to take the 4, negative 4, and distribute it. So negative 4 times 2x squared gives me negative 8x squared. Then I'm going to go negative 4 times a positive 3x. That's going to give me a negative 12x. And then negative 4 times negative 5, that's going to give me a positive 20. Now I look for like terms. So I have 8x squared and a negative 8x squared. Well, those would cancel with each other. Then I look for another like term. I have a negative 6x and a negative 12x, which gives me negative 18x. And then I notice I have this positive 20, nothing alike to it, so it's just going to be plus 20. And that is how we multiply a monomial to a polynomial and also do the addition step or combining like terms at the end. It's basically just distributive property first and then combine whatever like terms we have.